Okay, let's dive straight into this explainer and discover how the laws of indices are actually brilliant mathematical cheat codes. If you have ever sat in a Cambridge mathematics exam staring down a massive, sprawling algebraic equation and thought to yourself, there literally has to be a better, faster way to do this, well, you are absolutely right. Indices were designed specifically by mathematicians to save you from endless, repetitive algebra that just eats up your clock. Today, as your strategist, I am going to help you decode these rules and show you exactly how to completely streamline your math workflow. We're going scene by scene to build your blockbuster answer, cutting out all the filler and keeping the action.
We have a very clear roadmap for our session today, taking you from the basic shortcuts all the way up to conquering those complex algebraic boss battles you see at the end of your papers. First up, we'll look at the ultimate math shortcut. Second, we'll break down the 4 core laws. Third, we tackle the rule benders, negative and fractional powers. Fourth, we'll put it all together by simplifying complex expressions. And finally, we will master solving index equations.
Section 1. The ultimate math shortcut. You know, to truly appreciate the cure, you first need to fully understand the disease. In algebra, that disease is long-form multiplication. Let's look at exactly why mathematicians invented this system in the first place.
This comparison brilliantly illustrates exactly why indices exist. Imagine you are under the intense time pressure of a Cambridge exam. Instead of painstakingly writing out the variable a multiplied by itself 8 separate times, which is not only physically exhausting but leaves a huge margin for you to accidentally lose count, we use a tiny number floating up at the top. We call it the index or the power. Writing a to the power of 8 communicates that massive algebraic operation instantly. It is elegance and efficiency combined. You cut the filler and you secure the marks without the hand cramp.
Moving on to Section 2, the 4 core laws. Now, what's really interesting about this next segment is that once you memorize these 4 foundational rules, almost any index problem on the 0580 syllabus becomes totally solvable. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get into the actual mechanics of how we manipulate this incredible shortcut.
Math isn't just magic, you guys. It's pure logic. Take a look at this visual proof. You can literally count the a's here to prove exactly why a cubed times a to the power of 5 perfectly equals a to the power of 8. Think about it. By expanding a cubed into 3 separate a's and a to the 5th into 5 separate a's, and then multiplying all of them together, you can visually see all 8 a's lined up in a row. This proves exactly why our very first law works so flawlessly. Instead of expanding it all out and wasting precious exam time, you just add the indices together. 3 plus 5 is 8. Boom, you've got your answer in 2 seconds.
I need you to take a mental screenshot of this table right now, because these 4 core laws are the absolute foundation of your algebra arsenal. Let's break them down. First, as we just proved, when you multiply terms with the exact same base, you just add the powers. Simple. Conversely, when you divide terms with the same base, you do the opposite. You subtract the powers, m minus n. Now, what if you have a power raised to another power, like a to the power of n, with all of that raised to the power of m? In that scenario, you multiply those indices together. And finally, the golden rule that examiners love to test, any base raised to the power of 0 always equals 1.
So let's talk about that last rule, because the crucial point here is that a to the power of 0 equals 1 isn't just a random trick. It's a logical certainty derived directly from the division law we just talked about. Let's walk through the steps to prove it so you never forget it. Start with a cubed divided by a cubed. Basic primary school math tells us that any number divided by itself is simply 1. 10 divided by 10 is 1, a million divided by a million is 1. But if we apply our slick index division law to that exact same problem, we have to subtract the indices. 3 minus 3 gives us 0, so we're left with a to the power of 0. Since both methods are solving the exact same problem, a to the power of 0 absolutely must equal 1. It's a beautiful piece of mathematical logic that will secure you easy marks.
Section 3. Negative and fractional powers. Let's see how our strategy builds when we introduce the rule benders. Because let's face it, Cambridge examiners aren't just going to give you nice, neat, positive whole numbers. They want to test your limits.
Here is where I see thousands of students lose easy marks. A negative index does not mean a negative number. Let me repeat that. It does not make the number negative. It actually flips the term into a fraction. The absolute most common mistake students make under pressure is seeing a to the power of negative n and automatically writing down a negative value. It's not. That negative sign floating up in the air is simply a command word. It's an instruction telling you to find the reciprocal. So a to the power of negative n simply becomes 1 over a to the power of positive n. It just flips it upside down.
And just as simply, a fractional index is nothing more than a disguise for a root. It turns intimidating fractions into basic square or cube roots. A to the power of 1 over n is the exact same mathematical concept as the nth root of a. So, if you see an index of 1/2, don't panic. It's just a square root. If you see an index of 1/3, it's just a cube root. This simple translation is incredibly powerful and strips away the complexity the examiners try to throw at you. Section 4. Simplifying complex expressions. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, now it is time for the boss battle. Let's apply all these rules simultaneously to dismantle a terrifying algebraic fraction.
Do not let a massive fraction like this cause you to panic. When you open your exam paper and see a chaotic jumble of numbers, A's and B's all mixed together, your brain might try to overload. But we are going to use our cheat codes to slice through it one single piece at a time. The secret strategy to tackling this is realizing it's not one giant problem, it's actually just 3 separate simple problems stacked together in a trench code.
We're going to use a strict divide and conquer strategy here. By isolating the steps, handling the whole numbers first, then dealing with the a variables, and finally the b variables, this monster equation instantly breaks down into simple, bite-sized arithmetic. First, handle the whole numbers exactly like you normally would. Multiply the whole numbers on the numerator together, then divide by the whole number on the denominator. Completely ignore the letters for a second. Next, focus your eyes only on the a terms. Use your addition law to combine the top, then use your subtraction law to divide by the bottom. Finally, you just repeat that exact same process for the b terms. It's a foolproof framework.
And after neatly working through those steps, we arrive at this incredibly satisfying and remarkably clean final answer, 18b squared. Let me walk you through exactly how we extracted that. First, for the standard numbers, we had 12 times 3 on the top, which is 36. Divide that by the 2 on the bottom, and we get 18. Write that down. Now for the a's. On top, we had a to the power of 1 times a squared, which becomes a cubed. But wait, we divide that by a cubed on the bottom. 3 minus 3 is 0. And as we proved earlier, a to the power of 0 is just 1, so the a variable completely drops out of the equation. Finally, for the b's, b cubed times b to the power of 1 gives us b to the 4th. Divide that by b squared on the bottom, 4 minus 2 leaves us with b squared. Put it all together, and we land perfectly on 18b squared. That is how you secure full marks.
Finally, let's move into Section 5, Solving Index Equations. For our final stage today, we shift our mindset from just simplifying expressions to actively solving equations to find a missing value.
This right here is a classic exam twist. It's when the base number is known, but the power itself is an unknown variable, like an x. Now, this can look super intimidating because pretty much everything you have learned up to this point has had the x grounded on the floor level, not floating up high in the air as an exponent. How on earth do we bring it down?
The absolute best trick here is to force both sides of the equation to speak the exact same language. You need to rewrite them so they share the exact same base number. Once you do that, it instantly exposes the hidden index. For example, if you're given the equation 2 to the power of x equals 16, ask yourself, can I express the number 16 as a base of 2? Yes, you absolutely can. 16 is exactly the same thing as 2 times 2 times 2 times 2, which is 2 to the power of 4. So you rewrite the equation to read 2 to the power of x equals 2 to the power of 4. Since the bases on the floor are identical, they're both 2, pure math logic dictates that the powers in the air must be identical too. Therefore, x equals 4. You just bypass the complex algebra by matching the basis.
I hope you now see how these logical laws transform confusing, messy algebra into an elegant puzzle you can easily and efficiently solve.
From saving you from writing endless variables, to managing tricky fractions, to finding hidden powers, these cheat codes will save you immense time on your actual exam. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.